For every action, there is an equal and opposite reaction. That is Newton's third law of motion. But what does this really mean? Newton's first law describes the motion of a single object when no net force acts on it. It either stays at rest or moves at a constant velocity. Newton's second law describes what happens when a net force does act on a single object. The object accelerates. Newton's third law involves two objects interacting with each other. Each exerts an equal and opposite force on the other. To see this law in action, I'm using a LabQuest, two Vernier force sensors, and a rubber band. Connect force sensor 1 and force sensor 2 to channels 1 and 2 of the LabQuest. Turn on the LabQuest. You will see a red box and a blue box, showing that both sensors have been identified. Now, zero both sensors so they read 0 when no force is applied. Then reverse one of them because the forces we are studying act in opposite directions. Finally, connect the two sensors with the rubber band. Click the green Collect button to start recording. Case 1. Force sensor 1 pulls, force sensor 2 does not. Let's study the graph. The two forces are equal in magnitude and opposite in direction. Case 2. Force sensor 2 pulls, force sensor 1 does not. Again, the graphs show equal and opposite forces. Case 3. Both sensors pull on each other. Even now, the forces remain equal and opposite at every instant. Object 1 cannot pull on object 2. With a force greater than object 2 can pull back. That is the essence of Newton's third law. Please subscribe, like and share for more fun science. Happy learning. Thank you.